right, so my name is Kito Mann, and this session is called Scale Up with GraalVM and AWS Lambdas. So let me share my screen. Let's get started. Okay, so hopefully everybody can hear me all right.
Yes, we can hear you and see your screen.
Excellent, excellent. Okay. And let me make sure I have this visible and make sure that I have this visible. Whoops, got too many things going on here. Bear with me for a second. Okay. All right, I'm back now. Okay, so this session is called Scale Up with GraalVM and AWS Lambdas. Thanks for coming. I'm glad to see everyone here at JCON-ONLINE 2022. Very glad to be at this conference. Just as a process note, I've got a couple other sessions today as well. So next one is on GraphQL, and then I've got one later on getting things done, which is just pure productivity stuff, but also fun as well. So a little bit about myself. My name is Kito. I'm the principal consultant at Virtua, which is my own little consulting company, where we do training, mentoring, development, architecture, etc., and with a wide variety of technologies, obviously with a core focus on Java, but also for web development as well. So we've worked with Angular, React, and web components is really our preference. And for Java stuff, everything from all of the Jakarta EE stack to microservices, microprofile, all that kind of fun stuff. And of course, AWS. I am a Java champion. I've been involved in the Java community process back in the day for a lot of enterprise technologies like CDI, portlets, JSF. I even wrote a book on JSF a long time ago. And I'm a member of the Jakarta EE Guardian Leadership Council. So just basically the Jakarta EE Guardians is a group that helps promote the use and development of Jakarta EE technologies. And that includes everything from servlet to JPA to CDI, JSF, older stuff like that as well. I'm also a Google developer expert in web technologies. I host a podcast called Stack Podcast. So if you like podcasts, I encourage you to check it out. We talk about just enterprise software development in general, front end and back end stuff, and we have lots of interesting guests on as well. So I encourage you to check that one out. And also I speak at lots of conferences, obviously. So that's my story. I'd love to hear a little bit about the audience. So I'd like, basically what I'm wondering is how many people here have worked with GraalVM before, and how many people have worked with Lambdas before. So I just want to get an idea from the audience about sort of where everybody is. If we could just put that in the chat, that would be great. And hopefully I can find the chat. Chats. Okay. So moderator, could you tell me this client is a little bit different than I'm used to for Zoom. So is there anything in the chat right now? So I'm going to take that as a no. All right. Okay, yes, I'm not seeing a normal, there's the normal chat, okay. All right, so actually now I'm seeing it, okay, sorry about that. I was looking in a completely different part of the Zoom client here for some reason. Okay, so let's see, we've got a lot of no's, which is great. One person used GraalVM to compile Java effects, used AWS Lambdas for periodic batch jobs. Heard of it, work with Lambdas. All right, excellent. Okay, you've come to the right place. Just so I can give you a sense of my background, I've done a huge variety of technology stuff over the last 20 years or so. But in terms of Lambdas, I work with Lambdas a decent amount and AWS a decent amount, parts of AWS. AWS is so huge that I don't think anybody's worked with all of it. Most of the microservices stuff I did actually was with Java without not running as Lambdas, running just using ECS, Elastic Container Services, which is sort of like Kubernetes. That was actually using Dropwizard, which is kind of old these days, but it was a precursor to a lot of the microservices frameworks that we have today. But we did use Lambdas a lot, but we used them mostly with Python. And some TypeScript and stuff. And when I worked on that project where we did all that, I talked about using GraalVM and Java, and people laughed at me. This was a couple years ago. So I'm very happy to show how it's done and how you can consider using it in your projects. All right, so first let's talk a little bit about GraalVM. So GraalVM is really just an umbrella project from Oracle. It originally started in Sun Labs many years ago. Now it's Oracle Labs. I think it was actually Sun something else, but it's basically their lab, their experience, not experience, what do you call it? Experimental organization. So now it's Oracle Labs is where it came out of, and it actually was included in some of the earlier JDKs. JDK like 9 through 16, I think, had like a version of GraalVM, but then they broke it out into a different project, and I think that's a really smart thing because now we all know about it as its own thing. So the first thing to understand is that GraalVM it works with OpenJDK, so you can actually compile normal Java apps with it. But it has a couple very massive features. One feature, which I'm not really covering here, but I do think is worth mentioning, is just the polyglot capabilities. So, whoops, did not mean to do that. Hold on a second. Let me go back up here. So it supports lots of different languages. So obviously it supports all the JVM languages like Java, Kotlin, etc., Clojure, whatever. But it also can support a whole bunch of other languages using this truffle implementation framework, which basically allows it to support many other languages. So it actually supports JavaScript, but actually supports Node. So you can actually write complete Node applications using it. Also, you can write Ruby, R, C, C++, which is what the LVM is in there. R through that as well, and also WebAssembly, which is sort of like bytecode for the JavaScript virtual machine. And what's nice is it can run all those different languages, but you can also interoperate in between them. So let's say you wrote code in Python, but you wanted to access the Java library that you had, you could do that as well. And this actually, I think, would be helpful in situations where you are, let's say you've got like a lot of Java code and you're just writing some Lambdas to do some gluing, but you need to reuse some of those libraries. This is a good use case. Like you might want to use GraalVM, and then you can write a quick thing in JavaScript or TypeScript or Python, but still use a library that you're using in your like full enterprise microservice. So that's one of the features I think is worth mentioning. Not our focus today, but wanted to mention it. Our focus today, of course, is native image. And native image basically just takes a look at all your Java code, figures out what classes are actually being called in your code, and then creates a binary executable for the given operating system. So basically you move from having a JVM load and then start up and then load classes dynamically, which is one of the benefits of Java, to something where it knows what the classes are right away and can start up a lot quicker. And also because it doesn't have to load any classes which are not being used, the actual startup time, the execution time can be faster as well. and also the memory footprint can be small. So basically, native image is really more about performance, and it's more of a, to me, I think of it more of a deployment mechanism. I don't know if I would use it every day, for writing code, because there are a lot of limitations, which we'll talk about later. But you can look at it as another way to deploy your code. So I did want to mention, just for Oracle's sake, that there are community and enterprise editions of GraalVM available. Of course, with the enterprise edition, I'm sure you get lots of extra goodies and support and all that kind of fun stuff. But it's a really extensive and well-documented project. So, all right, so that's great. So how does it work, this native image thing? So the important thing to think about is, well, I sort of talked about how it works. You basically find all the code in your application and then create binary out of it. That's a very simple approach. But mainly, it's this closed world idea, okay? So this is my closed world image. And you can think of it as basically the idea that the application world is closed, meaning you can't load any new classes dynamically, okay? And they call it the closed world assumption, okay? And as a consequence, I'll just fix that there. As a consequence, there are some limitations. And I think this is an important thing to consider if you're going down this route. Can't use the security manager, invoke dynamic, and invoke dynamic method and method handles is not available. Finalizers are not invoked. Fortunately, these are not very commonly used things. So unless you've got some legacy code where they write finalizers, or you're doing some fancy stuff with invoke dynamic, you're probably not going to run into it. You may have some old code around which uses the Java security manager, but that's not really, it's pretty much deprecated anyways. So it's probably time to get rid of it. I think what's a little more interesting is that there are some things that behave differently. So unsafe memory access, you have to sort of explicitly say that if you're using anything from the unsafe package. The deprecated thread messages. I love this just-in-time editing here. This is a new presentation, so you'll get to work through my kinks with me. So deprecated thread methods have been removed, like thread.stop. Class initializers are a little bit different. You can actually execute class initializers during build time, which is a completely different way of thinking of things. So there's some nuances you can look into along those lines. Signal handlers are handled a little bit differently as well. You have to explicitly tell GraalVM to handle those, otherwise they're disabled. So there's some nuances there. But honestly, the biggest difference is this deal here, which is reachability metadata, okay? So basically, a lot of the standard things you do in Java, like reflection and serialization, you may or may not do, but reflection and resource bundles are pretty common things that you need to do. Also, serialization, JNI, Java Native Interface, dynamically generated classes, etc. All of these things require metadata because they aren't really officially supported by GraalVM, because GraalVM wants a closed world, right? And all these things are dynamic. So, loading classes, creating classes dynamically, inspecting classes dynamically, loading resources from a class path. That's the dynamic thing, JNI, etc. So all these things, you basically have to tell GraalVM, hey, I'm going to do this. So you basically say, this class has these methods that I want to be able to expose, or this resource bundle, here it is. Why don't you just include it inside of the binary? So basically, there's a lot of hints you have to give GraalVM in order to make the native image work. And you can do this either in JSON, and in some cases you can do it in code. And there is a lot of stuff that we can sort of figure out automatically. So there's a tracing agent that you can run that can figure out a lot of these, a lot of this metadata automatically for you, but generally you might want to tweak it afterwards. So to me, this is the biggest overhead. And there's a couple other things. when it comes to debugging, if you want to debug a native image using your normal Java tools and stuff, you're kind of out of luck, because it's now compiled binary code. It's not, byte code talking to it being loaded by a JVM, right? So if you want to debug it, you can use a native debugger. Like I think the GCC debugger is what people normally use, or maybe it's JDB. And you're kind of out of luck there, which is why I think it's really more suited, for production deployments than for local development. There is a VS Code extension that allows you to do some debugging, but you still have to, it basically goes through the native debugger in order to work. So those are some of the limitations. I do want to mention that all these specialized limitations, right? But especially with reflection. Also, I left out dynamic proxies. That's another thing that requires additional metadata. That's why if you start using Quarkus or Spring Native or Micronaut, if you start using their native function features, you'll have all these specialized packages that are like, variants of things you're used to, like, CDI or JPA or whatever, that are specifically for native. And the reason is that they have all that metadata. Also, there's some issues with CDI that have been ironed out in order for it to work inside of a native image. And there's actually a new spec called CDI Lite that removes some of the stuff that doesn't work too well in native images. But that is why they have a lot of special packages. So the good thing about picking a framework like one of these, is that they have actually done the work for the metadata for most of the stuff in that ecosystem. So it does simplify the process. And what's nice is now that the AWS SDK for Java 2.x now has GraalVM metadata in it, which is pretty cool. So, we're getting support, and the idea is that, if there's a library that you really want to add support without doing it yourself, you can of course ask them to do it, ask them to add the metadata, or create a PR for it if you've developed it, or if you've generated it, et cetera, et cetera. So that's sort of the story there. So that is zoom out of this. To start with the native image. I'll talk a little bit about AWS. So, and I'm sorry, AWS Lambda. No one can talk about all of AWS. So Lambda is really, think of it as a runtime, or a system which allows you to have a runtime to run a function. And so basically there's a single entry point. And the main benefit is that AWS handles all of the scaling and fault tolerance, failover, provisioning, etc. So that's really the main thing, is that you write a function, you throw it in AWS, and it runs everything for you, and doesn't charge you when nothing's running. And that's the other main thing. So whereas a lot of, if you're running like a Docker container with your code in it, and you just keep it running all the time, you're paying for those resources if you're running in the cloud. With Lambda, you're not. You're only paying for when it's actually being used. And that's kind of the main benefit. The other perspective I see with Lambda as well is that it's basically the glue between the AWS services. So AWS has dozens and dozens of different services. And often you need to do a little bit of processing. You may need to respond to an event from one service and do something else. And while a lot of the sort of talk around native deployments is based on endpoints that people talk to from HTTP, like a REST endpoint. Lambdas in general can be used for anything, like you may get an event from a database, like a write to a database, and then you want to, read something else and then log it, or you want to put something on an event queue, or you want to, push out a response to something via WebSocket. Like, who knows what you want to do, but basically you can respond to all these different events with a Lambda. And to me, that's really the kind of key benefit, on top of just, another way to provide a microservice. So the way Lambda works is they basically have a Lambda service, okay, and then you have your API, and usually in situations where you have an external facing Lambda, you're going to have an API with API gateway or something. It'll talk to Lambda, and it runs inside this special execution environment. So it turns out this execution environment is really something called micro VM, which is this sort of special Firecracker micro VM, which is a special execution environment used for Lambda and Fargate and services like that, that basically is really efficient and really good at segregating different processes. And of course, it's supposed to be able to start up things very quickly. So and that's actually open source, so you can take a look at that if you're curious about how that works. So Firecracker is used, and it basically launches your container stuff. But if you think about what's happening, it's actually a little more simple, a little simpler than you might think. So I'll jump over to this site here. Okay, so there's a site GraalVM on Lambda, which I do not recommend using the demo on the site, but it's a useful site to look at. The demo is a little bit outdated. So this is what we see with a normal Lambda, okay? And there's actually something called a runtime interface client. So basically the Lambda service just makes a request, a network request to this runtime interface service, which calls your function code. That's really all that's happening. And in the Java world, that runs inside of the Java runtime, okay? So out of the box with a Lambda, you can support a Java runtime, Node, Python, I think Go as well, lots of different runtimes. So basically all that's happening is the service is calling this runtime interface client, which has a certain API to call your Lambda. That's really all that's happening. And it turns out you can actually create your own custom runtime. So while there are a whole bunch of runtimes which come by default, including a default Java one, there is one you can use. You can create your own, and your own runtimes can run however they want. And that's how you can create a GraalVM native image. You basically create a native image, which is a binary. Okay, it has the runtime interface client and the function inside of it, and then that's going to run inside the Firecracker micro VM. And that's pretty much all that's happening. Now, the magic, of course, is the fact that by having this functionality, Amazon can, start and stop different Lambdas really quickly, and it can also, basically that ability allows them to scale a lot. And of course, they can shut them all down if nothing's in use. So that's basically what's happening with Lambda. Now, the caveat is that if you, because your Lambda is not always running, you have this thing called a cold start, right? So when the Lambda is not running and it gets the first request, it needs to be instantiated. And that is the reason people like using native on Lambdas. So if you start up the JVM, normal JVM, it takes a while to start up and get going. It's optimized for long running sessions. So, the JVM and the just-in-time compiler get a lot smarter over time as your application runs. But it takes a while for that to happen. So with GraalVM, it's sort of like everything is done up front, so it's faster to start. Now, maybe, in some situations over time, it's not actually faster for each request. But the startup time is a lot faster. And if you're dealing with situations like this with Lambda, where you have short operations you're trying to perform, and the container may be stopped completely, you want that startup time to be fast. A lot of these scripting languages like Python and JavaScript don't have this problem because they don't have to do a lot of stuff when they start up. So they tend to be used a lot more for Lambdas because they're faster to start. They don't have a cold startup problem. So using a GraalVM native image lets you avoid the whole cold startup problem and put you on par in performance with the other runtimes, which is nice, especially if you have like a whole bunch of Java developers and you need to use existing libraries in your Lambdas. Makes a lot of sense. So let's look at a quick demo and see how much time we have here. All right, we'll see how we do here. Okay, so what I'm going to do is show a demo which is actually pure Java. I'm not using Micronaut or any fancy frameworks, just to show you, because my main interest is showing you about Lambdas and the native builds in GraalVM. If you use those frameworks, I imagine they'll make things simpler in some ways. I haven't worked with them specifically for the native support, so I can't really tell you, but I'm sure they, provide things that make your life a little bit easier. Okay, so over here. Okay, so I'm going to show you some code. Hopefully everybody can see this okay. Hopefully this is big enough for everybody. If it's not, please let me know in the chat and I will adjust accordingly. All right, so let me start out here. Let me close this stuff. Okay, so over on the left here, I've got a function, okay? And it is an ordinary Java function, okay? Here is the POM for it. This one is JDK 11. And when I get time, I'll bump this up to 17. But we've got just 3 dependencies. We've got the Lambda Java core, Lambda Java events. So you need these in order to actually respond to Lambda. And this other dependency, which we'll talk about later. And then we have the Maven shade plugin, which lets us create a big fat jar, which most of us are familiar with these days if you've created any sort of fat jar at all. Actually, I will leave out this. Okay, you can ignore this part right here. But this is the shade plugin, which will create a nice fat jar for us. Okay, so let's see, we'll talk about that later. Okay, so it's pretty simple. It's a pretty simple POM file. And we've got a very simple request here. So this is a AWS Lambda request handler. And you see it's got a very, very complicated amount of logic here. We basically just output hello world as content type text. That's pretty much all we're doing here. And the system out println was just for testing purposes. Obviously, in a real application, you would use some sort of logging library. So this is our Lambda. Very exciting, right? So basically, what we want to do is we want to build this function, and then we want to deploy it, right? So this one is very, very easy to build. Okay. So this is my terminal. I'm going to go to the function, and I'm going to do Maven clean install. Actually, let's do that. All right. Woohoo! Okay. So I've got my jar file here. I'm good to go, right? And it should go back to the shaded part real quickly here. Okay, so the reason this is here is so that this is, of course, the main class which gets loaded, which is the runtime, which will then implement, which will then execute your code. So this is all fun Maven stuff, very simple and straightforward. I've got my jar file. Now I want to deploy this on AWS. And of course, there's different ways to do this. I could actually do it all through the console. But since this is a Java programming conference, I will be hip and do it through infrastructure as code. So AWS, like any platform, any cloud platform, has a whole bunch of infrastructure as code tools out there. And lately they've added something called the CDK, which is pretty handy. So the CDK lets you basically write your infrastructure as code using actual programming languages as opposed to Terraform or YAML, which is nice. and then you can use that to create your entire application and provision all of the AWS resources that you need. So you can very easily, once the CDK is something you have to install separately. It also helps to install the AWS CLI as well, which I've installed. But basically, once you've done that, once you've installed the AWS CLI, you've set up your credentials, you can just do CDK init, and then it'll create a little scaffolding app for you in whatever language you choose. So usually for this kind of work, I work with, like, Python is probably my preference, or TypeScript, but they also support Java. So I figured it makes sense to use Java here. And the API is actually really nice. So basically you make your app, right? Your app consists of a stack. The stack is actually something handled by AWS CloudFormation. And basically this stack is what your app includes, and you, of course, can add other stacks as well and other information. Right now, we're picking up all the credentials for this deployment from the AWS credentials file, which was configured via the AWS CLI. But the stack part is where the interesting stuff happens. So, so this is my stack, and I will comment this out. Talk about that later, and we'll leave this out for now. And basically what we're doing is we're creating an HTTP API endpoint or HTTP API in an API gateway. And we're calling it GraalVM Lambda demo. And then we're configuring the function. So we are basically saying, okay, we want to create a function. This is the name of the function or the ID of the function. This is where the jar is. This is the handler that we want to be called. And we can specify how much memory we have and log retention, all that kind of fun stuff. Then once we've done that, we need to basically bind that to API gateway, and that's what this route is here. So we're adding a route, we have a path that we wanted to respond to, and then we're integrating it with, we're basically creating an integration between the API gateway and the Lambda. And then we just have some output. So once the build is done, we'll have a little bit of output to say, what the URL is of the build. Okay. So this is basically how we can deploy things. And what's nice about this is that it's repeatable, right? It's very easy to make changes. You just run CDK deploy over again. So what I'm going to do now is just run this. So go here. I'm in my infra folder. And I can do CDK deploy. And one thing I left out is that there is this little CDK JSON file, which gets generated for you up front, which basically says, this is what we're doing. This is essentially the main work that we're doing. And of course, different dependencies. So, okay, so it's creating my change set. I've already built my app, so I had to build it first. Now we're deploying, right? So updating my stack. So I've already done this before. So of course, there's already an existing CloudFormation stack. And while we're waiting for that, actually, so what it's doing here actually is this deleting some of the other stuff I had before. So that's why it's taking a little bit longer. Okay, we're done. All right, so now I should be able to go into the AWS console and see what happens. So I can go to CloudFormation. Whoops. Hopefully. Okay, actually it's loading now. Okay, cool. Okay, so these are my CloudFormation stacks. The only ones we care about right now are this one. which is the GraalVM Lambda stack. So this GraalVM Lambda stack has these resources in it. So what's nice is that all of these things were created by what I just did, essentially. So we've got some CDK metadata, we've got Lambda permissions, my Lambda function, log retention policy, IAM, which is the identity access manager roles, etc. So we got all this stuff was created, which is nice. I can also go over to right. Before we go to Lambda, let me go over to API Gateway. Okay. So I've got one API, which was created, and it has one route. You saw we configured the routes, and the route is hello world JVM. Okay. So this is the normal JVM version of a GET request. I mean, of the function, excuse me, and it is a GET request. And so there it is. And then we can also look at the Lambda itself, which is what we're looking at here. Okay, so very exciting. But you can see there's the API gateway configuration as well. Okay, so there's my Lambda. So what I can do now is I can execute it. And since it's really simple and doesn't do anything, I can actually take the output that we have here. I can actually scan it properly. And I can just do a curl. All right, there we go. Hello world. Got my response back. So woohoo! I did a very simple Lambda, but no GraalVM, but it's Lambda. So that's cool. Now, that was nice to see. Let's see if we can see what actually happens. So this is the Lambda, right? And if I go down here, I can go to the logs. And let's see, 224. 224. Okay, so let's see if we've got. Unfortunately, it takes a little while for logs to show up in CloudWatch. This is one of the joys of a cloud infrastructure, is that we got to wait for the logs to show up, but they should show up soon. All right. So here is our actual output here. And if you look at this, you can see that my Lambda did run, and there's that system out println that I had. Okay. But for the purposes of our discussion, this stuff is kind of interesting, right? So we've got the build duration, which is 15 milliseconds, the duration. So it took about 14.8 milliseconds to run. And you see this init duration. This is how long it took for AWS to get this runtime up and going. So the initial request took about 14 seconds. You see it used about 88 megs of RAM and the memory size was much larger than we needed. So this could help you tune the memory size too. There's no reason to provision 2 megs if you don't need it. I'm sorry, 2 gigs if you don't need it. So so that's what we got. Okay, now so that's a cold start, right? Because we saw the initialization time. Let's see what happens now. So that was really fast, right? Right. Sorry about that. Yeah, so let's see if we can get that last result, which should hopefully be a warm start. You don't really have complete control over it, but theoretically it should be a warm start. Spent way too much time in my life waiting for logs to show up. Okay, so So I think while we're waiting for this, should be there in probably like another minute or so. Let's jump to I'll try one more time. Jump to the next topic here. All right, so in a second, we'll find out how long it took for a warm start, right? But we know that we're looking at, roughly 14 seconds for the first request, right? 40 milliseconds, excuse me. 14 seconds would be very bad. All right, so let's say we want to do GraalVM because we want to speed up the process. So what do you have to do? A few different things. First, you have to install GraalVM. So I have several JDKs on my machine, and you can install GraalVM the same way you install any of the other ones. Like I actually used a brew. The instructions tell you to do it differently. Just do a curl and get it. I'm sure there's probably other package managers you can use as well. And I actually use JN to switch between my different JVM implementations. So if you can also use Kito Mann as well. So JN actually versions. So these are all in JDKs I have installed. Some of these are the same version. And there's GraalVM. And so what that tells you, first of all, is that I used GraalVM just as my normal JDK to build the first app, and that works fine. You can basically consider it just an open JDK implementation at that point. So first you got to install GraalVM, then you also need to use the Graal updater tool, GU, to install the native feature. And right now it doesn't really have many things you can install, but basically you do GU install and then the name of the package, which would be the native image here. If you do GU available, really the only two options are the LLVM toolchain. I think is useful if you're implementing support for another LLVM language or a native image. So you do that, and then you're good to go. So let's take a break and go back and see if we got our results yet. Okay, so now you see that on the second hit, we got 2.32 seconds, okay? So the code's 2.32 milliseconds, excuse me. So the code has a huge performance hit for the cold start, right? And that is what people are trying to avoid by using the native image, among other things. So now we know what the JVM version looks like, the normal JVM version. Let's look at the GraalVM one. All right, so we already saw the function. That's pretty much the same, okay? The actual POM file is a little bit different. So the other dependency that we had here was the AWS Lambda Java runtime interface client. Quite a mouthful, but essentially this lets you support a AWS Lambda custom runtime using Java. And you need to do this if you want to support a custom runtime, whether or not you're using GraalVM, if that's what you want to do. And a custom runtime, remember, allows you to basically use something other than one of the standard runtimes that AWS provides. So someone says I can improve the port performance by using the latest release of GraalVM. This is true. I almost did that. So, all right, so we're running a little slow on time, so I'll speed this up a bit. But there is a plugin that we have here called the native image plugin. And so this allows us to create a native binary. Okay. And so we do that creates a binary file for us. It's actually the main class is going to be this AWS Lambda class, which again is the runtime API. So it's going to use that as the main entry point for the binary, and then the binary is going to call our function. There's also the Maven assembly plugin, which is going to create a zip file for us because that's the deployment method that we're going to use. Actually, this was already here, I'm sorry. But yeah, so this is the zip file actually is still going to be used for what we're doing. So, so that's the story there. The code is the same, but there's a couple other nuances here. So the first one is that all right, let's go back to functions here. Okay, so basically, in order for the runtime to execute, it needs this bootstrap file. And this is really more for the custom runtime. It's not a specific GraalVM thing. It's a Lambda thing. So this basically says, run the binary, and this is the name of the handler, which is this class right here. Okay, that's one thing you have to do. But then, of course, you have to worry about all this metadata we talked about, right? So first, you have to put in your own metadata. So here we have to put in the name of our function because we want that to be available via reflection. See is reflect config.json. And then we also need the configuration for all of the AWS stuff. And this is what you would need for any other third-party libraries that use any features which Graal needs help with, like reflection. So these are all of the latest metadata for these versions of the AWS libraries. But you see there's information about reflection. There's information also, what's in here about, let's see, resources as well, okay? These are resources which are the native libraries for this, for the runtime client. So, so all that needs to be specified as well. Then once you've done all that fun stuff, in your infrastructure stack, you just need to provision the actual custom runtime. So that method is down here, and it's pretty much the same, except what we have to do is we have to actually run the build on the target operating system, right? So this is an M1 Mac. I cannot, if I build it here, it may work, but it's not going to work on the target Amazon Linux runtime. So, so you got to basically build in that container. And now if you're using like a continuous integration system, you could just do it there. But here what we're doing is we're using an image, which is actually an ARM image. One thing I highly recommend is don't try using an x86 image of Linux on a M1 Mac. It will cause you nightmares. It does theoretically experientially work. Experimentally work. I don't know if that's a word. Theoretically, it sort of works, but not really. So basically, what I'm doing here is I'm using the ARM Amazon Linux image that has GraalVM and Maven in it as well. And we're actually using a ARM instance machine architecture for the Graal VM. So ARM is actually cheaper on Amazon, and it's actually a new option, relatively new at least. So this actually works out well. But if you are using x86, an x86 image, you'll have to do that on a machine that can support that. So that's basically what's going on here. So I will run this quickly, and we'll see what happens. So we've done the build. We've done a normal build, right? Now, when we do the CDK deploy, what it should do is take the jar file that we already created and then use that to create a native executable in the Docker image. So let's see how that works, because I've uncommented stuff. Taking a little bit of time to start. Yes, this is my build running inside of the Docker image. And this one is a GraalVM 22. I just hadn't upgraded locally. So this is doing the build using the Maven plugin.
Hello, Kito. We have
Hello.
about 2 or 3 more minutes, then we need to change to the next stream.
Okay. All right, so while this is building, are there any, I don't think there are any questions, are there? Let's see. Oh, yeah, someone else said if I went into the log stream, I could find the actual event quicker. I tried that before, but what I wanted actually was the timing, which doesn't seem to show up in the log stream. Anyways, so now it's saying you're making some changes. Are you sure you want to do that? And I do. Well, while we're waiting for this, may I have a couple minutes? Any other questions? Okay. All right, so this will be done in a couple minutes. But I did want to point out a few things, which a few words a few things I realized working on this, which is that make sure you have an up-to-date example to work with. A lot of the examples out there are even just a few months old or like a year old. It may not work the way that you expect. Obviously, I mentioned the issues with the M1 Mac. Another thing which I ran into, which is that incomplete metadata or incorrect metadata can actually cause your application to have unexpected results. So it may run fine, but then actually not produce the expected results. So if you run into that, that may be the problem as well. Okay, so this now is running, has completed. I'm going to grab the GraalVM URL here. Do a curl. Okay, there's my hello world. And then I'll do one more curl. That was a lot faster, right? So then if I run over here and I go over to my GraalVM function, which should now be here. Okay. Hopefully it will show up in a minute. And let's see if the stream shows up sooner. I don't think it will. Okay, fair enough. It show up sooner. Okay, so the first one, is this the right? No, this is the, I think this is the right one. Okay. All right, so it's interesting to see here. So the first hit, see had a start duration of 15 seconds or 15 milliseconds. I keep on saying seconds, and a much smaller footprint of like 51 megs or 2.56, or I'm sorry, 51 megs was the actual footprint. The memory size we specified was 256. And the second one was a lot faster with a duration of 0.96. And what I found, now you notice the startup time still isn't that fast, right? The cold start was not fast. I found that if I did it a second time, it actually got to be a lot slower. I mean, a lot faster, excuse me. So the results that I found when earlier were a little bit more appealing. If I can get to my app here. All right. If you look at the timings I had before, we saw the JVM starts, but the GraalVM starts, actually, the cold start was down to 3.85 seconds. So we think there may be something about the very, very first time that happens with this custom runtime. But in subsequent cold starts, it was actually down to like 3.585 milliseconds. And of course, the speed for the warm is really fast. So what I saw was, this is just obviously anecdotal evidence 40% reduction in memory, 45% reduction in start time, and a 70% reduction in cold start response time. This should be response time. So that's a pretty nice benefit. And the main thing that you'll find is that over time, that memory, using less memory is obviously gonna help you out a lot in terms of costs. So that's sort of my story. And I will wrap up. Obviously, as I said before, working with other frameworks might, make your life easier.
Kito, we have 1 more minute, then we need to change the stream.
Okay. All right. Well, thanks a lot, everyone. The last thing I'll leave you with, there are some links. I'll certainly provide the slides. Also, before you jump on the Lambda bandwagon, just decide if it's what you really need. Because if you're just writing a microservice, you could just use something like AWS Fargate with ECS or EKS, which is EKS is the Kubernetes, managed Kubernetes, ECS is their sort of own container service. But essentially, it gives you similar functionality in terms of elasticity and the ability to create lots of instances and tear them down dynamically with a normal Docker image that you don't have to do special stuff with. So I think there's pros and cons, but this is one approach which you can add to your toolbox. So thank you very much, everybody. And again, I'll make available the slides, and I'll also make available the demo. I haven't done that yet, but I will. So thanks a lot, everyone.